Okay, we're going to go through 9 examples I have here to review kind of together, and then you guys will have a quizzes you can work on over the weekend or starting today. We are going to be testing on Monday because this really isn't that hard of a test. Again, a lot of this stuff, even though we had 4 different lessons, a lot of these lessons really were the same thing. It was just a new shape with a new property, but they were all looked at very similarly. So we're going to start with some of the easy questions first, and then we'll work down into the harder questions where we have to actually solve an equation. So let's look at example 1. So this was the new stuff. This was the always, sometimes, or never type of questions. So when you're doing these questions, you always want to refer to your Venn diagram here. Remember, if the first shape is entirely inside the second shape, that's always. If the first shape is only part of the second shape, that's sometimes. And then if it's just not true, it's never, or they're not part of each other at all, which is not going to be any of our cases here just because of the way that we're doing this and the shapes that we have. Let's go ahead and take a look. A square is a rectangle. So I'm using my finger today because I left my stylus at school. This is our first shape. This is our second shape. Let's go ahead and look. Here's square. And then we have rectangle. I'm going to go ahead and choose a different color. This is my first shape. Is it entirely inside my second shape, rectangle, only partially inside or not inside at all? It's partially inside. Oh, sorry. It's entirely inside. Here's square. All of square is inside rectangle. Rectangle is the whole circle, and all of square is inside it. So this is going to be an always question. A square is always a rectangle because a rectangle just needs to have right angles, and a square has right angles. So this is an always. Okay, let's look at this one now. Now, this one's a little bit different. So some questions you're going to have where it's like, this shape is this shape. And then we can look at the circles and figure out kind of where it is from there. Sometimes you're going to have questions, though, where it's a property. A square has an obtuse angle. So what you want to do first is you want to look to your properties. Now we're talking about a square. So I'm going to scroll down to square. And we want to see, first off, if that property is here. Now, kind of a hint here, guys. If a square doesn't have this property, it's not going to be anywhere else because a square has all of the possible properties we talked about. It comes together in this. So let's look at what we see about the angles. We have opposite angles are congruent. Okay, consecutive angles are supplementary. Let's see, 4 congruent sides, congruent diagonals, 4 right angles. Well, if it has to have 4 right angles, then it can't have an obtuse angle because an obtuse angle, you guys should know, is greater than 90, right? So if a square has to have all 4 right angles, it can't ever have an obtuse angle because they have to be 90. So sometimes with these properties, the answer can be never if it's just outright false. A square cannot have an obtuse angle by definition. All of the angles are right. Okay, let's keep it going now. So now, again, we're going to be referring back to our properties. So I'll kind of be flipping back and forth to that. We know this process. We determine, are we talking about sides, angles, or diagonals? We look at our properties, we come back to our picture, and we apply the property. Now, again, guys, I cannot say enough how important it is. You follow with your finger, you draw the picture on your paper, and you know what angle is being talked about. So we have SQU. You have to know what angle is being talked about. We have S to Q to U. This whole thing is 44 degrees. We are trying to find SQD. So follow, again, on your paper, from S to Q to D, we want this angle. That's a little question mark right there. So hopefully we remember these properties by now, but we are talking about angles. And this is a rhombus. Be very careful that you are looking specifically at rhombus properties and nowhere else. Let's go to our property sheet. That's a square. I don't want to look there. Rhombus. What do we know about angles? Well, we know that opposite angles are congruent. Okay, we got consecutive angles are supplementary, but those are specifically talking about different corners of the rhombus, and we're looking at just one corner of the rhombus. Let's keep going. 4 congruent sides, diagonals bisect angles. So looking back to our picture, our angles are cut in half. That's bisect, right? So we are given that the entire angle is 44, and we just want half of it. So what should the measure of angle SQD be? 22. 22 is half of 44. That gives us the 22 degrees. Be very careful, guys, because again, it's possible that I was given half the angle and I want the whole angle, and then we should multiply by 2. This is why I say it's so important that you know what you're looking at. Here, we wanted half the angle. It's possible in another question, we're given half and we want the whole. Pay very close attention to what angles are being talked about. Let's try it again. So same thing here, we got angles. We're going to be very careful about what's being talked about. We have D to S to Q. This angle right here is 33 degrees. We want to find D to I to S. D, oops, to I to S. That's the angle we want. There's my question mark. So this one's a bit more complicated. We need to find this little half right here, but we only know this little half. So we're talking about this angle to start with and this one, right? We have half of this angle, but we're looking for half of this angle. So to start with, we know something about these angles that are consecutive. These are consecutive angles, S and I, because they're on the same side of the rhombus. So let's go ahead and look to our rhombus properties. What do we know about consecutive angles? Consecutive angles are supplementary. They add to 180. So S and I, that's going to equal 180 degrees. Now, what we have, is half of S, and we want half of I. So what I'm going to do here, I'm going to kind of erase this, get some clear stuff going here. This is 33 degrees. So to start with, we know from the last question that in a rhombus, this isn't true for all shapes, so be very careful. In a rhombus, my angles are cut in half. So if I know this is 33, what does this angle have to be? 33 as well. So this whole angle is 66 degrees. That's angle S, 66 degrees. I don't know if you can hear Major. He's sitting at my feet and he's asleep. He's making sleepy noises. I think I woke him up. Okay, going on. So again, 33 is what we had. We know this has to be 33 as well. This whole thing is 66. And again, we're trying to find this angle right here, which is part of angle I. And most importantly, it's half of angle I. So if we know angle I, we can find half of it and we're done. So I'm going to go ahead and solve for angle I here. I want you guys to try that. Here's my equation, solve for angle I. We should subtract 66 over to get angle I by itself. We've got angle I equals 180 minus 66 is 134 or 124. Sorry, I should know this. Actually, 114. So even teachers need calculators. Whoops, 180 minus 66. 114, wow, I was off by a lot. Okay, is 114. So all of this is 114 degrees. And we want to focus on, keep your eye on the goal, right? Our goal was D to I to S, and that was just half. So our actual answer here is going to be half of the 114, which is how much? That should be 57 degrees. If the whole thing is 114, half is 57. So when you guys are doing these questions, sometimes it's helpful to find everything. Okay, well, I have 33 here. That gives me 33 here. That gives me 66. I know this whole thing is 114. And then you can ask yourself, what do I actually want? I have everything. I just got to find the one we want. If I know this, again, I knew this was 57. This was 57 as well. You can look back here and go, okay, I found every angle. Which one did I actually need? Sometimes that's a good strategy. Okay, let's keep it going. So we still got a couple more easy ones. I think 2 more before we start looking at the equations. We've got a parallelogram here. So when we look to our properties, we're now going to be looking at just parallelogram. We have R is 165. We're trying to find angle C. So these are angles. And more importantly, remember that by now we should know, we need to know if we're talking about consecutive or opposite angles. What are these two? R and C, are they consecutive on the same side of the parallelogram or opposite across from each other? These are opposite. So they are again across from each other through the shape. Let's look to our parallelogram properties for anything about opposite angles. Hey, look, right here, opposite angles are congruent, which means if this is 165, this also has to be 165. Super duper easy. Because we knew they were opposite, that's why they were equal. That's our thinking we have to have. This is also 165. Keep in mind, these two are not equal. Those are consecutive and they have a different relationship that's on our property sheet. Okay, so we need to look at what's being labeled here. Here is where it is super important you know what's being labeled, because just looking at this, RS and RC, I don't know if those are sides or diagonals. I have to look at the picture to figure out if I'm given sides or diagonals. So looking at the picture, what is this? Sides or diagonals? These are diagonals. And that's because here's RS, that's 46. And what we are looking for is RC. We're looking for the whole diagonal. So let's go to parallelogram. We're going to look at diagonal properties and see what we have. So let's see, diagonals. Hey, here's the only property about diagonals. The diagonals bisect each other, which means they are cut in half. Bisect means cut in half. So now we need to apply that, but what we need to do is, how do I use it? It depends on what we're asking for. I am given half, because this is bisected, this is cut in half. This whole thing is cut in half. Here's half. I want the whole. So if half is 46, what is the whole thing? Well, 46 plus 46, or 46 times 2, right? RC, the whole thing, if this is 46, this is also 46. All together, 46 times 2 gives us 92. Be very careful, guys. We are not automatically going to just double it. For example, say this question said, find SC. Well, then my answer would be this one, 46. Because they wanted the whole, that's why we said 92. So be very careful. Yes, the properties are always the same, but how we apply them can change depending on what we're asking for. Let's keep it going. Now we're into the hard ones. So now the hard ones, again, are the equations. So obviously these are angles, which is good. So we know that eventually we're going to be looking to our properties about angles. I'm going to go ahead and label on my picture what I have. I have 5x plus 18 is here. Whoops, why did I put 15? 5x plus 18 is this angle, angle A, and then angle B, we've got 3x minus 6. So we ask ourselves, because we should know this by now, we are talking about two different angles. Are these angles consecutive or opposite? These are consecutive angles. They're on the same side of the shape, right? They're both on that side. They're not across from each other through the shape. So let's look to our properties. Again, we're looking at, just parallelogram. And let's look for the one that says consecutive angles. Hey, consecutive angles are supplementary. So let's take that back. I want you to try to write the equation. You guys know this by now. I really hope so. Supplementary means add to 180. These two angles, add together and equal 180. Write your equation. Okay, let's check. These are my two angles. Whoops. Again, having to write with my mouse today. It's a little rough. 5x plus 18. Here's my two angles. They add together and they equal 180. Good. So if you haven't already done so, I want you to take a moment to solve and then click continue when you're ready. Okay, here's my equal sign. These are on the same side of my equal sign. So we have some like terms we need to combine. We've got 5x and a positive 3x. That is 8x. We've got 18, a positive 18, and a negative 6. That's a positive 12. Remember, if you aren't sure, guys, use your calculator. You've already seen, like in this video, I've had to use my calculator like 3 times. Yeah, it's okay. Use your calculator. 18 minus 6. And solving from here, now we are moving across an equal sign. And that's why now we are doing the opposite. We didn't do the opposites before because we were combining like terms. 180 minus 12, 168. I'm going to double check that with my calculator because I don't know when it's too early. Yes, 168. And then we're going to divide by 8. So let's see, we got x equals 168 divided by 8. This is 21. Now, we are good geometry students, and so we go back up to the problem and we make sure, because we want to make Miss Holberg proud, that did I only need to solve for x, or did I need to go back and plug in? So let's check the problem. We needed to plug in. So here's angle A. We're going to take our x equals 21, and we're going to plug into this. Go ahead and try that. Okay, measure of angle A is what we actually wanted, and this is the answer that would go into Canvas when we're doing our test. I'm taking my x, I'm popping it in to the x position, 5 times 21 plus 18. We get measure of angle A is 123. And that's the answer I would put in. Always double check, guys. Don't just like wash your hands of it and move on. Possible, X is your answer. That is possible. But we want to go back. We want to double check and see if it is or isn't. Okay, we got 2 more here that are the tricky ones. So once again, we're dealing with angles. We know that we are going to want to figure out, are these consecutive? Are these supplementary? Or is it just one angle we're talking about being cut in half? That's a possibility too. Now this is 2 separate angles. Angle A and angle C. So we got 4x plus 27. And we got 6x minus 23. So what are these now? Are these consecutive or opposite angles? Opposite. These are now across from each other. Through the shape, these are opposite. We are looking at a parallelogram. We go to our parallelogram properties. And right here, opposite angles are congruent. So you guys should know by now, write your equation. If those 2 angles are congruent, what's our equation? They're equal. So 4x plus 27 equals 6x minus 23. Let's go ahead and solve for x. Take a moment to do so. Okay, so again, I'm going to do this one way. Wait until the end to see if you did it correctly. No matter where you started on this, you should be able to get the same answer. We got 2x minus 23. Gonna add 23 over. Again, I'm doing the opposite all the time here because I'm moving across an equal sign. Notice I'm moving over an equal sign. Yep. So 27 plus 23 should be 50. Yeah. And we'll divide that by 2. We get x equals 25. And we are good geometry students, so we go back up and see what they want. We need to find angle B. Now, this is a hard one. because we only have equations for A and for C, and this is what we want. However, we should know this. If I can know what C or A is, because they're going to be the same thing, we can actually find B using a different property. So we're going to go ahead. It doesn't matter which one you plug into. This is the magic of math. I'm going to take my x equals 25. I'm going to choose an equation to plug it into. And then we're going to see how can we find angle B. So I'm going to go ahead and plug my 25 into C. It doesn't matter though. I could plug it into A. The magic is it's going to be the same thing. So we get 6 times 25 minus 23. We get 127. So what I'm going to do here on my picture is I'm going to erase this right here. I'm going to replace it with 127. Now, if I know that this one is 127 and my end goal, keep your eyes on the prize, right? Always see what's the end goal. My end goal is to find B. I know this is 127 and I know something about these two angles. What should these two angles do? They add up to 180. These two are consecutive angles, so they add up to 180. I hope you guys realize by now that if I want to find angle B, and I know what this one is down here, we can just subtract from 180, and then we have the angle that we want. So again, measure of angle B plus measure of angle C. We know those are going to equal 180 degrees. They're consecutive angles. They add to 180. So in order to find B, I'm just going to take 180. I'm going to subtract the measure of C, and this is going to give us B. So we have reached our end goal of 53 degrees. Super important, guys. That's probably going to be one of the hardest questions on the test. You want to keep your eyes on the prize. Where are you going? What do you need to know in order to get there? Okay, we have the last one we are at here now. So let's look. Once again, this is a tricky one where just looking at these labels, I do not know if these are sides or diagonals. So look at your picture. Tell me, are these sides, angles, or diagonals? These are diagonals, actually. We look at our picture here. We've got Z to V. That's a part of a diagonal. And then we have V to X is 23. This is a parallelogram. Let's go look at our parallelogram properties and see what we know about diagonals. Hey, we should know this by now. We should start to have these kind of memorized because we've been working with them for so long. The diagonals cut each other in half. So what we need to realize to ourselves here is, what am I given? Am I given both halves? Or am I given a half and a whole? Because that will change things. Be very careful. Are we given two of the halves, or are we given a half and a whole? We are given both of the halves, right? I know that from here to here is 1/2 of the whole thing. And I know that from here to here is another half. So even though those are both halves, what that means is they are going to be equal. If I have half and you have half, we have the same amount. So if those two things are equal, write your equation. Okay, our equation should be 3x plus 2 equals 23. We should be able to solve this very easily by now. I hope our algebra skills are coming back to us. 3x equals 21. We're going to divide by 3. We get x equals 7, and we are good geometry students. Keep our eyes on the prize. We're going to go back up and see what the prize is. Find the value of x. Sweet. We're done. This is our answer. We don't got to go back and plug it. Okay, now that I've gone through these questions with you guys, now you're going to go ahead and try quizzes on your own, making sure that we're being super careful and going slow. The common mistakes with these questions are just not paying attention, going too fast, just being like, yeah, it's this, and not thinking twice about it. So be very careful when you guys do the quizzes, and you guys will be